You'll hear me talking. Okay, so we're going to go over this review here for Unit 1, and we're going to start this with question number 1, which says, describe in words what the midpoint of a line segment is. First off, mid means it's in the middle, and point means it's a point. So a point in the exact middle of a line segment. Okay? It has to be the exact middle. It has to be a line segment. If it's a line, there is no middle. It goes infinitely in both directions. If it's a ray, it goes infinitely in one direction. It can't be the exact middle. It's garbage. So you really have to have a line segment. Question number 2, find the midpoints of the following measurements. The way to find a midpoint is to take the first endpoint, add the second endpoint, and then divide that by 2. You basically take the average of those two numbers, and that will be the point in the middle. -4 plus 4 is 0, divided by 2 is 0. 5 plus 15 is 20, divided by 2 is 10. And hopefully on those first two, you should have been able to just figure that out looking at it. But if you can't, there's a formula. On the third one, I don't blame you if you can't figure this one out immediately. -7 plus 22 is going to give us 15. So then when we take 15 and divide by 2, we get either 15 over 2, 15 halves, or 7.5. And then the last one, halfway between 350 and 450. I mean, I already know what that should be off the top of my head, but just in case you're not sure, 350 plus 450 is 800, divided by 2 is 400. So the midpoint of 350 and 450 should be 400. Hopefully none of that provided too much of a challenge. Question number 3 is still asking for midpoint, but it's a word problem. Freddie is saving money to get a Switch. His parents already gave him $125 for his birthday, and he knows that it will cost him $400 with the games and case he wants. What would be the midpoint between what he has now and his goal? So this is going to be $125 plus $400, and then I divide that by 2. That means it's 525 divided by 2, which should give me $262.50. Now, I'm not actually that fast at doing that in my head. I memorized it from the earlier class period. Okay? At $262.50, he will be halfway between what he has now and his eventual goal of 400. On number 4, the conditional statements, identify the hypothesis. I'm going to circle the hypothesis. And the conclusion, I'm going to underline the conclusion of each one, then write its inverse, converse, and the contrapositive. If it is Monday would be my hypothesis. The hypothesis always goes with the if statement, and it does not include the word if. So it is Monday is my hypothesis, and I will eat a peanut butter and jelly sandwich is my conclusion. In case you didn't know what PBJ is, it's peanut butter and jelly. Grape for preference, but you do what you want. Okay, so this is the original statement. If P, then Q. The inverse is where we add the word not. Okay, we add the word not to make the inverse. If it is not Monday, then I will not eat a PBJ. Okay, I just add the word not to both sides. That makes the inverse. To make the converse, And the converse, all I do is swap the order of the hypothesis and the conclusion. If I eat a PBJ, then it is Monday. And then the last one, the contrapositive, is where I do both things. I swap the order and I add the word not. Since I already have my converse right above it, I'm just going to add not to both parts of my converse. If I don't eat a PBJ, then it isn't Monday. Okay, so that's how the inverse, converse, and contrapositive are going to work. Example B, if it is Tuesday, then tacos are on sale. Oh, glorious Taco Tuesday. My inverse on this one is going to be, if it is not Tuesday, then tacos are not on sale. Oh, I forgot to identify. It is Tuesday would be my hypothesis. Tacos are on sale would be my conclusion. My converse is if tacos are on sale, then it is Tuesday. And then my contrapositive, if tacos are not on sale, then it is not Tuesday. Okay? Again, on the inverse, I'm adding the word not. On the converse, I'm switching the order of the original. And on the contrapositive, I am doing both things. I am swapping the order and I am adding the word not. Now, this last one, I put an example like this on the review for a specific reason. This one says, we will go swimming if it does not rain. The hypothesis is in the second half of the sentence. It does not rain is my hypothesis because it goes with the if statement. Okay? Regardless of the order that it's spoken, because this is still a proper sentence, regardless of the order that it's spoken, the one that goes with the if is the hypothesis. We will go swimming is going to be my conclusion. So my inverse on this one, if it rains, I can't add two nots. If it does not rain, that's silly. If it rains, we will not go swimming. The converse, which is where we have to think of this in the original order, and then swap it. If we go swimming, then it will not rain. And you can see how this changes the meaning of our sentence. Our contrapositive, if we do not go swimming, then it is raining. Okay. Now, question number 5 says, go back to the previous question. That's question 4. So examples A, B, and C. And determine the truth values of each statement, including the ones you wrote. Which types of statements should be logically equivalent? Which statements should be biconditional? Statement A, if it is Monday, then I will eat a peanut butter and jelly sandwich. Depending on the information that we have on this one, it could be true. We don't have any other information, so we don't know if this one's true. We're going to call it false. If it is not Monday, then I will not eat a peanut butter and jelly sandwich. Well, you could eat one any day of the week. Again, if we had more information about the whole situation, we might be able to make a different conclusion, but here it's just false. If I eat a peanut butter and jelly, then it's Monday. Now that would be interesting. The act of eating a sandwich makes it a certain day. If I do not eat a peanut butter and jelly sandwich, then it is not Monday. Again, if that first one were true, if we knew that this person ate a PBJ every Monday, we could say this last one's true. The original and the contrapositive are logically equivalent. They are linked. The inverse and the converse are logically equivalent. They are linked. So they should have the same truth value. Letter B, if it is Tuesday, tacos are on sale. This is true, especially depending on the restaurant, but we'll just say for now, it is definitely true. We can use Fuzzy's or Taco Cabana or Rosa's as our example of tacos being on sale on Tuesday. If it is not Tuesday, then tacos are not on sale. This one is not true. Tacos could be on sale for an entire month, and not every day in that month is a Tuesday. If tacos are on sale, then it is Tuesday. Again, it's logically equivalent of that inverse, so it's also false. And then if tacos are not on sale, then it is not Tuesday. That one's true. Okay, again, the original and the contrapositive should be linked. The last one is a weird conditional statement, so depending on how we write it, different things can happen. We will go swimming if it does not rain. We can call this one true. If we do not go swimming, then it is raining. We can call that one true as well. If it rains, we will not go swimming. That seems true. If we go swimming, then it will not rain. Doesn't work, though. Okay? So we have to kind of false our way around this because of the way things work. That means that since none of these are true all the way around, none of them would really apply as a biconditional statement. Okay? Question 6. What does it mean when a line bisects another line? Bi means to, and sect means to cut. You've dissected animals in biology, or you will, and vivisect is to do the same thing while the animal is still alive. That's always fun. But bi pretty obviously means two. Bicycle, you know, 2 wheels. So this means it cuts the line into 2 equal parts. Anytime we bisect a line, it cuts it into 2 equal parts. So number 7 gives us an example. Line AB bisects line CD at point P. I'm going to draw a picture. You don't have to draw the picture, but this is just for illustrative purposes. This is line CD. This is line AB. And this here is point P. It has been bisected. Both of those measurements, at least if my drawing were better, should look exactly the same. So what do we know about CP and PD? CP as a line segment should be congruent to PD as a line segment. They are the 2 halves of that whole length of CD. Then number 8 asks us to do something algebraically with this information. Use 2x plus 8 for CP and 4x minus 5 for PD. What is the value of x? If this is a bisector, that means that these two are equal. So 2x plus 8 is equal to 4x minus 5. We add 5 to both sides. We subtract 2x from both sides. I'm combining because I have limited amount of space. So this is 13 is equal to 2x. I divide by 2, and I get x is equal to 6.5. So that's the first part. What is the value of x? X is 6.5. What is the length of CP? Well, CP is 2x plus 8. So 2 times 6.5 plus 8 is the same thing as 13 plus 8, which means CP as a line segment is 21 units long. We don't know what they're measuring in, but we know it's 21 units long. CD then is the whole thing. We don't have to put this stuff back in and find the other half. All we have to do is put this together. It should be 42. If half of it is 21, the whole thing is 42. Number 9, imagine that line AB intersects line CD at point P, but does not bisect it. So again, a picture for illustrative purposes. This is my CD again, but this time AB is over here. We've got a smaller area for CP and a larger one for PD. Using the same values from question 8, determine X if the total length of CD is 33 units. So this time we can't say the two halves are equal to each other. We're going to say 2x plus 8 is equal to CP. We're going to say 4x minus 5 is equal to PD. And the whole thing is equal to 33. We have to add together the two parts in order to make the whole. 4x plus 2x is going to give us 6x. 8 minus 5 is going to give us 3. So 6x plus 3 equals 33. I subtract 3 from both sides. I get 6x equals 30. So x is 5. One part would be 18. The other part would be, 15. 18 and 15 should go together to make 33. Number 10, what is the definition of an angle bisector? Again, bi means two. Sect means to cut. So this is, it cuts an angle into two equal parts. If we bisect a line, we cut a line into two equal parts. If we bisect an angle, we cut an angle into two equal parts. If BD is the bisector of angle ABC, this is number 11, and angle ABC is a right angle. What does that make angle ABD? Draw a picture to represent your answer. Again, you can't draw a picture if you're doing it digitally necessarily. I've got this nice 90-degree angle that is A, B, and C. It's a right angle. And then I've got a ray through the middle that is BD that's cutting it into two equal parts. Well, if I take 90 and cut it into two equal parts, that means ABD is going to be a 45-degree angle. Number 12, we're coming to the end of what we did as far as the geometry was concerned. Define complementary angles and supplementary angles. Complementary angles will add together to make 90 degrees. So on the question we just had there on number 11, those two would be complementary angles. They add together to make 90. But understand that they don't have to be directly adjacent to one another. They don't have to touch. If I got an angle out here that's a 30-degree angle, and I have another angle that's a 60-degree angle, then these two angles are complementary. They add together to make 90, regardless of where they are. The supplementary angles, it's a similar thing. They add together to make 180 degrees. Now, understand that with both of these, we're talking about two angles. We're not talking about like 5 angles that come together to make this. So if we're thinking of a triangle, For the supplementary, that won't work. It has to be something like a linear pair. Okay? Any linear pair, angle 1 and angle 2, is going to be a set of supplementary angles because they will add together to make 180. But also, if I have an angle over here that's 100 degrees, and I have an angle over here that's 80 degrees, that will also be supplementary angles because they add together to make 180. Okay? And then our last question. If angle 1 is complementary to angle 2 and angle 2 is complementary to angle 4, what relationship, and this should be do, I had a typo on here, I'm so sad. What relationship do angle 1 and angle 4 have? If they're complementary, they add together to make 90. Angle 1 plus angle 2 is 90. If they're complementary, they add together to make 90. That's angle 4 and angle 2 make 90. Since they both make 90, we can set them equal to one another. Angle 1 plus angle 2 equals angle 4 plus angle 2. If I subtract just the value of angle 2 out of there, I end up with angle 1 is equal to angle 4. They are congruent. We don't even need to know their measures. We know that they both add together with the exact same angle to make 90. So based on the information that we have there, they are exactly the same. Okay, I'm going to stop the YouTube video.